verify ready for launch. FTS.
FTS go.
Props go. AVI.
AVI's go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Good morning and welcome to our live coverage of SpaceX's Starfall Demo Mission. Our Falcon 9 rocket is currently awaiting liftoff from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida, with liftoff scheduled for 6:53 a.m. Eastern Time. Hello everyone, my name is Zachary Lupin and I'm an avionics supply chain engineer here at SpaceX. And thank you so much for joining us for the 74th Falcon launch of the year. SpaceX has developed a new spacecraft called Starfall, which is at its core a microgravity lab researchers and entrepreneurs can leverage to develop their products and innovations. As we have seen demonstrated on the International Space Station, there is a huge opportunity to benefit life on Earth through microgravity research and in-space manufacturing. During today's demo, SpaceX teams will be closely monitoring the first launch of the Starfall spacecraft, which has a primary goal of demonstrating controlled flight and splashdown in the Pacific Ocean. And as a note, we will not have views of the second stage today, and we will be closing the broadcast after the landing of Falcon 9's first stage. Speaking of the first stage, this will be the 29th flight of this Falcon 9 booster, having previously supported NASA's Crew 6 mission, mPOWER-B, USSF-124, Bluebird 1, PSN-N5, and 23 Starlink missions. Now, as of now, we are just about 9 minutes until launch, with teams currently tracking no issues. Weather is also green, with just a 5% probability of violation of launch constraints. However, if we are unable to launch today, a backup opportunity is available tomorrow, June 24th at 6:43 a.m. Eastern Time. So while the countdown continues, let's take a closer look at the launch vehicle supporting today's mission. The Falcon 9 rocket there on your screen is a two-stage rocket designed for the reliable and safe transportation of satellites, cargo, and people. Starting from the very top of the rocket, we have the payload fairing. That fairing is a protective shell that shields the payload from aerodynamic heating until the vehicle is outside of the Earth's atmosphere. Once in space, the two fairing halves will separate and fall back to Earth, where they'll be retrieved by a recovery vessel to be refurbished and reused on future flights. Now, both fairing halves flying today are flight proven, with one side flying for its 36th time and the other for its 24th. And if recovery goes to plan, those fairings will be pulled from the ocean and prepped to fly again. Now, right below the fairing is Falcon 9's second stage, which features a single Merlin vacuum or MVAC engine. And below the second stage is the black carbon fiber inner stage, and inside of that is where that MVAC engine is currently housed. And below that, we have the first stage, or booster, which shortly from now will be fully loaded with about 1 million pounds of liquid oxygen and RP-1 rocket-grade kerosene. Now, the first stage makes up the bottom two-thirds of the vehicle and has 9 Merlin M1D engines at the bottom, which generate more than 1.7 million pounds of thrust. And as I mentioned, today's mission will be the 29th flight of this Falcon booster. Now, about 2.5 minutes into flight, the first stage will separate and make its way back to Earth, and today the booster will be headed to our drone ship, A Shortfall of Gravitas, which is currently stationed in the Atlantic Ocean. Now, with just over 7 minutes to go, everything continues to be on track for launch. Now, by making launches reliable and frequent, SpaceX has become a key collaborator for researchers around the world. And that's changing how scientific discovery happens and helps enable research that benefits humanity. To date, our Dragon spacecraft has delivered more than 5,000 research experiments to and from low Earth orbit. These flights include missions to the International Space Station, as well as commercial and private astronaut missions. Dragon has supported research across biology, material science, medicine, Earth observation, and more. And this includes the Polaris Dawn mission, which is on screen now, which featured high-resolution bone health assessments designed to reveal the underlying mechanisms of bone loss in microgravity. The crew also tested blood flow restriction training protocols to improve the efficiency of on-orbit exercise.
Stage 1, RP1 load is complete.
And good call out there. The crew also tested blood flow restriction training protocols to improve the efficiency of on-orbit exercise, which is critical for future long-duration missions where crew time and resources are limited. On the From-2 mission, Dragon carried portable medical imaging tools to evaluate next-generation healthcare technology for astronauts living and working in orbit, and the crew even successfully performed the first-ever X-ray in space. SpaceX also supports regular cargo resupply service, or CRS missions, such as the CRS-31, which you see here, and the recently completed CRS-34, which delivered thousands of pounds of scientific payloads, crew supplies, and hardware to the International Space Station. With lower-cost access to space, NASA, universities, independent researchers, and more can conduct science more frequently. And now getting back to today's mission, next up in the countdown, the Transporter Erector, or TE, will begin to retract away from Falcon 9. First, we'll see the clamp arms around the second stage open, and then the TE will begin to pivot back, slowly swinging away from the rocket. Now, the TE has two components, a strongback alongside Falcon 9 and a launch mount underneath.
Falcon 9 tanks are pressing for the start of strongback retract.
And there's that call out as we get ready for the strongback retraction. Now, the launch mount has the 4 hold downs that'll release at T0. The TE does a lot of heavy lifting as it rolls Falcon 9 out to the pad, raises it vertical, and stays connected to the rocket through the final seconds before launch. It provides fuel, power, telemetry, and command connections between ground systems and the vehicle.
Strongback retract has started.
And there's that call out that strongback retract has started, and you can just make out those clamp arms as they begin to pull away from the Falcon 9 second stage. Those clamps help stabilize the second stage during fueling and prevent movement in high winds. Once they're open, the rocket will be fully free at the top, but will still be held down at the base. And with those clamp arms fully open, we should start to see the strongback slowly move away from the Falcon 9 rocket. Now, at this stage in the countdown, the rocket is nearly fully loaded with about 1 million pounds of propellant, and that includes rocket propellant 1, or RP1, a highly refined kerosene, and liquid oxygen, or LOX, which is chilled to roughly 300 degrees Fahrenheit below zero. Now, coming up shortly, we should hear the call-out indicating that LOX loading will have finished up on the Falcon 9 first stage. We should hear that call-out in just a few seconds from now.
Stage 1, LOX load is complete.
And there's that call-out. Now, the first stage finishes fuel loading at around the T-minus 3 minute mark, as we just heard, and the second stage will finish loading about a minute from now. And looking ahead into the count, at the T-minus 60-second mark, Falcon 9 will enter startup, and at that point, the rocket's onboard flight computers will take over. And from there on out, the countdown will be fully autonomous. And then just inside of T-minus 2 seconds, the 9 Merlin 1D engines will ignite, and once they're at full power, Falcon 9 will lift off from the pad and begin its climb to orbit. And we should be hearing that call out for Stage 2 LOX loading completion in just about 10 seconds from now.
Stage 2, LOX load is complete.
And there's that call out that liquid oxygen for the second stage is now fully loaded, completing propellant load for the upper stage and prop load overall. Falcon 9 is now fully loaded with 1 million pounds of RP1 and LOX. And coming up shortly, we should hear the call out for gas closeout starting.
Ground gas closeouts.
And there's that call out. Gas closeout has started, and that refers to venting and closing out gaseous systems, such as topping off tanks and sealing vents to maintain pressure. And coming up in just a few seconds, we'll hear that call out that Falcon 9 has entered startup. Should hear that in just about 10 seconds from now.
Falcon 9 has entered startup.
And there we heard that Falcon 9 is in startup, and the autonomous flight computers have taken over the count, with both Falcon stages pressurizing for launch. We're just waiting for our launch director, or LD, to give the final go for today's mission.
LD, go for launch.
And great news there, LD is go for launch. So let's sit back and watch as Falcon 9 launches the Starfall Demo Mission.
T-minus 30 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Go Falcon and go Starfall. Vehicle is pitching downrange.
M1D chamber pressures are nominal.
At T plus 30 seconds into flight, Falcon 9 has successfully lifted off from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. Now we're currently throttling down the M1D engines to prepare for max Q, which is the point of maximum
Power and telemetry nominal.
And good call out there for good telemetry. We're currently throttling down the M1D engines to prepare for max Q, which is the point of maximum aerodynamic stress.
Vehicle is supersonic.
For maximum aerodynamic stress on the vehicle. And max Q is reached when the air density of the atmosphere decreases faster than the increasing speed of the rocket.
Max Q.
And there's that call out for max Q. We've also got some wonderful views of the Florida coast as Falcon 9 ascends. Now we're going to have several events coming up in quick succession, starting with MECO, followed by stage separation, and then second engine start, or SES-1. Main engine cutoff, or MECO, is when all 9 engines on the Falcon 9 first stage shut down. This is then followed by...
MVAC chill has started.
And good call out there for MVAC chill. MECO will then be followed by stage separation, where the first and second stages are pushed apart from one another. And immediately after, the second stage engine, also called the MVAC, will ignite to continue pushing toward orbit. Now, this series of events is set to start in just about 25 seconds from now. We should be hearing that call out for MECO in just a few moments from now.
Main engine cutoff.
Stage separation confirmed.
MVAC startup.
And there we heard confirmation of those 3 events that happened back to back to back, which again were main engine cutoff, followed by stage separation, and then second engine start 1. Now coming up shortly, we'll have fairing separation, which is just about 10 seconds from now. Once the vehicle reaches the vacuum of space, the protective payload fairing is no longer necessary and gets jettisoned and retrieved for future reuse.
Fairing separation confirmed.
And there's that confirmation of fairing separation. Now, as a reminder, both of those fairing halves were already flight proven, with one half flying for its 36th time today and the other for its 24th. Both of those fairings will now be making their way back to Earth for recovery. Now, next up will be the next major milestone coming up will be the entry burn on our Falcon 9 first stage, which is scheduled to occur around the T plus 6.5 minute mark. Now, the entry burn is used to slow the first stage as it heads towards our drone ship, a shortfall of gravitas, out in the Atlantic Ocean. Without the entry burn, we'd only be using the atmospheric drag to slow down Falcon 9, which would add extra stress to the vehicle. The entry burn is similar to pumping the brakes to slow down the vehicle as it passes back into the Earth's atmosphere. And we need to slow down to reduce re-entry forces, which then helps us recover and reuse the first stage. And then following the entry burn, the booster will initiate the landing burn, which will slow the vehicle down even further for a precise touchdown on our drone ship. Now, during the entry burn, Falcon 9 is decelerating by firing its Merlin engines in the direction it's moving. And this causes the rocket to fly through the engine's exhaust gases, which deposits a layer of soot on the vehicle surface. And this is what gives our flight-proven vehicles their characteristic look. That soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little more on the outside skin of the vehicle. Falcon 9 is equipped with 4 hypersonic grid fins, and you can see 2 of them there on your screen, which are positioned near the top of the first stage, and those are used to steer the vehicle as it returns to Earth. These are the primary aerodynamic control surfaces for the first stage during atmospheric reentry and descent, and are a critical part of Falcon 9's reusability system. From time to time, you may also see white puffs coming from Falcon 9, and those are cold nitrogen gas bursts, which help with attitude control. Now, as a reminder, the Falcon 9 booster supporting this mission is flying for its 29th time today, having previously supported NASA's Crew 6 mission, Empower-B, USSF 124, Bluebird 1, PSN N5, and 23 Starlink missions. And we're just about 30 seconds away from the entry burn on the Falcon 9 first stage, and you should see the graphics.
Stage 2 FTS has safed.
And good call out there for FTS safing of the Stage 2. You should see the graphics light up as the engines do at the bottom left-hand corner of your screen. That entry burn is set to start in just about 10 seconds from now.
Stage 1 entry burn startup.
Stage 1 FTS has safed.
And there's that call out for the entry burn startup on the Falcon 9 first stage. This burn will last about 30 seconds, slowing down the vehicle in preparation for its final burn and landing.
Stage 1 entry burn shutdown.
And there we heard conclusion of the Falcon 9 booster's entry burn. Now, as I mentioned earlier, we will be attempting to recover this booster with our drone ship, a shortfall of gravitas, which is currently stationed in the Atlantic Ocean.
Stage 2 terminal guidance.
We should see that landing burn on the Falcon 9 first stage startup in just under a minute from now. As a reminder, you can follow the telemetry at the bottom of your screen. As those engines ignite, you can look at the bottom right-hand side, and you can also see the speed and altitude on the left. Now, as that burn happens, you'll see a drastic decrease in the speed and altitude as the booster comes in for a soft touchdown on the drone ship.
Transonic.
Impact shutdown.
We should be hearing that call out for landing burn startup in just a few moments from now.
Stage 1 landing burn.
And there's that call out for landing burn startup on the Falcon 9 first stage. And again, this is the final burn that this booster will execute leading up to landing.
Stage 1 landing leg deploy. Stage 1 landing confirmed.
And great news there, another successful first stage landing of our Falcon 9 booster. Again, this was the 29th flight for the booster supporting today's mission.
Nominal orbit insertion.
And there we also heard call out of nominal orbital insertion of the Falcon 9 second stage. Thank you again for everyone for joining us for today's demo as SpaceX teams evaluate a new spacecraft that will enable affordable, routine access to the microgravity environment for scientific research and in-space manufacturing. As I mentioned earlier, the goal of today's mission is to demonstrate controlled flight of the spacecraft and later splashdown in the Pacific Ocean. And because much of the action will happen later on, we'll be ending our live broadcast here. We'd like to thank the FAA and the Eastern Range for their support today, and of course you, our viewers. Be sure to check spacex.com/launches for the most up-to-date information on upcoming launches, and follow us at SpaceX on X. Thanks for joining, and we'll see you again soon.